Good morning everyone. I am Sekhar from IITR. Today I will discuss about the normal fault and the reverse fault under the guidance of Dr. Sandeep Bhatt. First of all, know about what is fault. Faults are defined when two adjacent blocks of rock have moved past each other in response to induced stress. In this field photograph, we can see that there is a completely moved past each other between two blocks. It's known as the fault. The motion of localized movement leads to genetically different classes of fault reflecting two basic responses of rock stress. One is the brittle, another one is the ductile, and their combination is known as brittle ductile. Then classification of normal fault. It is basically three factors are divided. One is the apparent movement of the rock block along the fault plane, the direction of the slip, the relation of the fault altitude with the altitude of the displacement bed. Then, on the basis of apparent movement, the fundamental types of faults are commonly distinguished on the basis of apparent movement: apparent normal fault or deep slip fault, apparent reverse fault or strike slip fault. Then, what is normal fault? A normal fault is a high angle deep slip fault on which hanging wall moves down to relative footwall. In this figure we can see that the hanging wall moves downward and the footwall moves upward. This is known as the normal fault. A normal fault brings the younger rocks over older one because of separation of the geological horizon arranges from the normally formed. Such as faults are known as the external fault. So we can see that this is a pure deep slip normal fault because it does not have any strike slip component. Then there is a topographic high in system, and if this topographic high this would erode with time, and it erode, then it would stay like this. Now if you do a field work here, you can figure out what you are walking on this rock, and then if you walking on a long side of this encounter a contact of another type of rock which longer than this, so your hanging direction will be this side. Plot on the field. The lithological contact are actually here. You can have a look here and then figure out what is the true lithological contact or a faulted contact. Then features of the normal fault. Normal fault that exist at all level of the crust. These are available at all level of the crust. The surface feature of faults vary with the shape of the fault, the depth of movement which fault occur. At shallow, normal fault develop cataclysmic shrinkage slides, shrinkage and lineation. The deeper structural level, normal fault develop feature associated with the ductile deformation. These are associated ductile deformation, including myelonite texture, which may be present shear zone 100 meters or 100 kilometers. Then there are normal fault, many normal fault occur. One is when normal fault differing away from each other, then they create a upthrown block. This is called host. So in this illustration, it was initially a straight layer, and then it had a normal fault on this side and this side another side fault in this side, and they are dipping away from each other, deep direction or opposite. So the dipping this side and this side is dipping this side, and this particular feature of topography elevation known as the host. These are the conjugate of the normal fault. Then discuss about the graben and the half graben. Normal faults are dipping each other and creating a downthrown block, which is known as the graben. Then also they are known as a half graben. In this, where do you not form the other conjugate sets and one set of extremely prominent, and these are known as the half graben. So you may subsidiary fault here, but major mastery fault this one. This is known as the graben, and this is known as the half graben. Then there is a domino model. In domino model, it is a very interesting features of normal fault and we can use it called a domino model. Domino model in which kids are play, even adults also play. So remember, little block like this, little block like this. This we align it different way, and then you push it and slide like this. Push it and slide like this. So this section of rotated version of the upper course is series of rotated fault. Having normal fault or off-on fault block arrange more or less dominus block or overturn books itself. Then rigid dominus side block is initially what you are like. It is initially like this, and then you have a 30 degree diff, and this is like this. Now when a large scale tectonic, particularly we have a rib tectonic, so may have a extensional tectonic hereafter, and these are all kind of domino structure as in a normal fault, and then over a period of time they shape like a bowl, and this is known as the domino structure, and they bloom here form. Then discuss about the master fault. Then discuss the master fault or subsidiary fault. The largest faulted area is called as the master fault. The largest subsidiary area is called as the master fault, and associated with the minor fault with is antithetic or synthetic. They are associated antithetic, synthetic. Antithetic fault dips towards master fault. Dips towards master fault, and synthetic dips towards same direction as the master fault. Subsidiary. These expressions are related to only making sense when minor fault related to the larger scale fault. Then what is reverse fault? Reverse fault can be compared a convergent boundary at both pieces unlocalized together. It is also known as when the hanging wall moves upward with the footwall. It is known as the reverse fault. In this diagram, you can see that as the reverse fault pushed together, the hanging wall sides up. As convergent boundaries pushed together, two faults are down, creating like a mountain valley. It is known as reverse fault. Then reverse fault. Reverse also known as a contraction, shorten the cross. Then contractional fault can occur at any scale from microscale to regional or orogenic subduction. Reverse fault in the last lecture we can fault are known as a contractional fault. Then, so we can see that the fantastic image in this. Trace the fault this one. Trace the fault this one. We can see that a particular white layer that one the offensive time together due to faulting, thrusting or reverse faulting, it had moved there for the entire cross got certain. It is a microscale or regional orogenic belt, and also in subduction zone. Then reverse fault. Reverse fault there is meaning features. Reverse fault with a low angle deep less than 30 degree called thrust or thrust fault. The term thrust fault is restricted to large structure. In this restricted sense, the fault is defined as a map contraction fault which have certain the arbitrary datum line. Thrust fault may show large horizontal displacement scale kilometer to kilometer. If the footwall stays position, the hanging wall transported, then it is called over thrust. Then called as the over thrust. If the footwall moves instead of the hanging wall, this is called under thrust. For rocks which travel along distance, very long thrust is described as the thrust shape. Then thrust. It is a little, there is a meaning cliff, thrust, cliff, window, etc. If a little unit have moved over the rocks in front of which is called as the allochthonos. When the little unit has moved the rubber rock, a rock mass which has not moved other rocks is known as the autochthonous. When there is no movement in the mass, is autochthonous. Para-autochthonous rocks which have moved other rocks to smaller. Para-autochthonous are moved autochthonous. Window and cliff. These are the erosional features. Also, Thomas would like to introduce the Windows cliff exposure. thrust safe associated main by erosion, it is known as the cliff face. And we can see that in a contractory, if you have allothenous material, they get eroded like exposure when it's allothenous rocks. When window, sometimes people it is called a tectonic window. Now this thrust, pole nappe or thrust nappe. Thrust nappe is a allothenous tectonic sheet which has moved thrust fault. In this case, thrust fault move. A pole nappe is a lithoid gives large stratigraphic inversion have initiated with a large recoupment. Here is the large recoupment, and in this case, the axial plane is the horizontal. The underlying limbs of this fold may be shear, thrust fold. The nappe might have not have its beds. It is not the fold nappe. There is a no thrusting. Due to thrusting, it has been then discuss about the thrust. Another type of thrust. When the liant allothenous rotationals if a window, these are mostly related with the thrust fold. Now, when we fold our the thrust fold are initially most is certain depth with propagate upward. Propagate upward. Now we can draw it here. So very little penny shape. A crack, and this crack has known as a close boundary between the top of the boundary propagating the direction with the known as the T-plane. This is known as the T-plane. Now one point is very important. Displacement of T-plane is the 0. Displacement T-plane is the 0. Then therefore is the definition of T-plane is the displacement of maximum and slowly along the displacement of a terminate 0. The blocks of either side of the plot line slice past each other, the tangent is a 0 degree. So what happening here? You from a zone here known as a process zone, and it is involved of ductile deformation and propagate the T-plane in the place. Now discuss about a different type of split. So we have a propagating thrust branch coalesce with another propagating thrust subsidiary. They are the isolated, diverging, connecting, and rejoining. Then there are two faults meet along bench line, and they meet. I will show you the ground surface on point and seen, and the ground surface that we see from erosion after the movement of siege contact and the ground surface of movement of eroding ground. So there is always an interaction between two fault. This is known as the lattice fault. Now a subsidiary is a branch of fault from the main thrust. Now this example, isolated play is characterized by the two T point. Isolated is characterized by the two T point. Two T points. That of the splay exposed in the trace fault isolated at the main stress. Now consider the oscillated has a nucleated body the master fault of both cases. Now isolated have splay vary. Now sometimes it is a diverging splay. Diverging means the T planes are divergent out from each other. Now there is the master fault with two or three master fault connecting each other, nothing to connecting splay. In this you can see that. Now this is rejoining. This is the rejoining of this. This is known as the rejoining of the. Then discuss about the ramp and flat. Thrust of regions have a ramp and flat or staircase trajectory. Ramp, this is known as the ramp. This is a and flat is the horizontal. The thrust cuts off section of ramp and follow the horizontal flat. The frontal ramp strikes are perpendicular to the transport direction. The frontal ramp will strike the perpendicular direction of the transport direction. Now dominantly reverse deep slip. A lateral ramp strikes more or less parallel to the transport direction. In this diagram you can see that, and hence dominant like slip. An oblique ramp direction is both strike slip and deep slip. Then discover out the imbrication. Thrust imbrication in this fault or fall land of an origin type from imbrication zone. An imbrication zone is a series of reverse faults that are connected with the low angle thrust fault. Initially there is no deformation. If the deformation continues, generally thrust with there is a number of 3 4 fault and push left side. In this one, push left side, they create a 2-3 fault, 2-3 deformation, and this 2-3 there is a imbrication. So this is the thrust imbrication. Then thrust, for example, Himalaya. For example, you can think about Himalaya, that will be a series of faults which are starting from the north STDS, then MCT, MBT, JMT, and MFT south. The youngest fault, then it is the angle fault, and SDD is the oldest. Totally initially first we have formed this, then this. So previous illustration, this is another type of thrust imbrication. This is a NFC, main Himalayan thrust. This is a good example of thrust imbrication. Then duplex structure. What is duplex structure? It is when imbrication do happen and a sole or floor thrust, that roof thrust at the top of the roof thrust bounce imbricated zone offered, completely called a duplex structure. So there is a sequence of, before we have developed a ramp plant model, we have again a plant, now sole thrust and the floor thrust, sedimentary cover, roof thrust imbricated zone offered, and a duplex structure complete form. A duplex structure consists of horses of iron piggyback basin. So piggyback basin. The horses are typically S shaped or J shaped. This is usually J shaped or S shaped, and the deep toward the hinterland. The horses can folded, rotated, thrusting into their primary geometric orientation modified. So in this case, the hinterland and horses folded and rotated during the thrusting, produce the fantastic structure learning about this. These are some references. Thank you.